having growing up on a dairy farm, that's really where my heart was. And in 2004, I took all my knowledge of cloud computing and I founded a software as a service for managing livestock. And that was a system a little bit like Dairy Comp or Bovisync. Everything was cloud based, so farmers would record information by text messaging or typing into a computer. But I sold that business in 2015, exiting in 2019. But I became very familiar with the problem that we all face, and that's how we get better data from farmers about their livestock. So you need better data to be able to improve genetics, to improve welfare, and also to improve efficiencies. And current ways of recording information, humans can sometimes make mistake if they're recording information, typing it in manually. And there are lots of sensor solutions out there, so wearable devices that are attached to the cows, and they're really great. However, they still rely on human commissioning, and a lot of large dairies find it tough to manage that amount of hardware. So what we've done with Catalyze is develop a video analytics platform, and that platform takes footage from low-cost security cameras to just very simple security cameras that are placed around a dairy barn. We pull that footage up into the cloud where we run various neural networks. So we've spent the last 2 years developing neural networks that segment out the cow, identify her, and then provide insights. And we then share those insights back to the farmer so that they can take intervention. And where appropriate in some of our retailer projects in the UK, we can share it across the supply chain. But the first insight, which is obviously very relevant to this evening, is a locomotion scoring / lameness detection system. So what we do is the cow walks past the camera and we give her a score between 0 and 100. Now that value proposition, going back to the farm level, is we believe by reducing lameness levels by 10%, there's a lot of research done on this in the UK, there's a saving of about $100 per cow per year. But there's also a carbon footprint saving as well, because as Gerard mentioned earlier, a lame cow is producing less milk. Her longevity may be impacted as well. And we've calculated as much as half a ton of carbon per cow per year to be got. Our system has been, in February, we ran we completed a validation study of the technology by the University of Liverpool. And I'll talk a little bit more about the findings from that research, which concluded that Catalyze outperformed a human in being able to detect cows with lesions. And the first sort of evidence that we're seeing at a farm level is we are seeing lameness reduction. And we've one particular farm in Wales, and they've reduced lameness from 25% down to 13%. And that's over a 4-month period, taking the data that we're producing and, of course, taking action on them. Because, of course, there's no point in just having the data if there's no action taken on them. These are some of the data that we're seeing around the early lameness detection. And you'll see the little blue line, and it's our locomotion scoring model. And you'll see that even before about 2 weeks before this particular cow had a toe ulcer that was confirmed by lifting her feet, her lameness levels were starting to trend up. Now, what we do is we score the cows between 0 and 100, and the higher the score, the more lame the cow is. And you're talking about 50 is that threshold of when a cow becomes lame. So we're seeing a lot of data that point to the ability to be able to detect lameness early, which ties back to Gerard's little graph with the blue bars and the grey bars, and how we can reduce that. And that's something that we're really focused on. Tiny bit of history about the company. I started it in 2019, working on a small dairy in the UK. I then started working with Tesco. Tesco are the UK's largest grocery retailer. And within the UK, you have a lot of retailers that have direct contracts with the dairy farmers. As a consequence of that, because of consumer concern, they pay a premium for the milk, but they do set certain standards. So they were very excited about this, because one of the big issues with detecting lameness and scoring cows is just the lack of consistency across humans. So they got very excited about the idea that we could develop something that could be consistent, not depending on humans that might make mistakes, and they were keen to get involved with us. So we raised some funding, we got a team together, and we really spent 2020 monitoring about 6,000 cows. The cows were monitored all the time, and we put experts on farm which would do the locomotion scoring, And we then fed that into an algorithm and developed a solution which we patented at a worldwide level. And we wanted to have the system academically verified. We started that in November 2020. But really, from this year, we really started rolling the product out. Following the academic study, we worked with both Tesco and M&S and a few other groups to start into the UK. And then in July, we got the system up and running on the black soil dairy, which Josh will be talking about. We also integrated with Valley Ag software in August, and we're currently working on Bovisync integration as well, because this data, we really need to put it into the hands of the dairyman to be able to make decisions based on other events, whether it's how long the cow's calved down, or if she's been trimmed already. You obviously don't want to trim her again, even though our scores are quite high. So it was very important that we integrate with the herd management system. Now, I'm going to give you a demo of the system in action, and you're going to see 6 cows walk past the camera. The bottom left camera is really the cattle eye camera. It's an overhead security camera, costs about $140. You just put it up over the exit race. The side camera we've got is just for the purposes of the presentation, so that you can see it. But you'll see 6 cows, and you'll see the ROM score, which is the UK model, which is 0, 1, 2, 3 in order of lameness. And then you'll see the cattle eye score, and the higher the score, again, the more lame the cow is. So if we start running the videos, hopefully you can see this. You see this first one is quite lame, and you see one of the human scores missed her, and we picked her up. So we would flag that cow. Next one is marginal. Third one is fine. A nice low score like that in cattle eye is perfect. And then you see this fourth one coming, and there's a little bit of a clue in the delay. And you'll see this girl's got a good bit of lameness issues there. And we scored her 63. So that cow would immediately be flagged to the farm to do something with. And then you'll see the next 2 are just no problems there. So that was the algorithm up and running. And then we wanted to get it actually validated by the university. So this was a study that was led by Professor George Economo, who's actually a colleague of Gerard's. I think they worked together in the US at some stage or other. But he ran a study across 3 farms and 1,400 cows. And what was happening was cattle eye was scoring the cows, but the experts. Cattle eye was scoring the cows over this period of time, and the experts were visiting the farm, giving their scores, but the 2 were blinded to each other, so neither could be swayed by the results of the other. And they wanted to really compare how accurate we were in picking up the lameness levels of each farm and how we compared with the human. So these were the 3 farms. They were a variation of smaller, larger herringbone rotary, and they all had an exit race. Some had a wide exit race, some had a narrower, some were indoor, some were outdoor. And really, the results we were absolutely delighted with whenever the guys were able to get together and start to analyze them. We found 89% agreement between the cattle eye and the experts. The experts agreed with each other as much as cattle eye did. And the first conclusion was that cattle eye was comparable to the expert human in the scoring. So this is when we compared just human scoring. But whenever we lifted the feet and started checking out in lesions, we found that cattle eye outperformed the human in terms of sensitivity and specificity, and actually selecting cows that had actual lesions. So we're really excited about that. The next stages for this study is we ran it on 3 farms. Now we've extended it to 7. And we're doing the same thing, making sure that the results match what the humans are seeing. Very importantly is how we're shipping this data back to the farm now. There is an app which will highlight lame cows. You can click on each cow and see them on the video. And we also push into the dairy comp system, the Valley Ag system, the Pulse system, so that those cows will appear on the trim list.